It's about strategies for using signals in a safe way. And in general, I have prepared several things for you I want to present from the perspective of an architect. The first thing is about computed, which is perhaps the most underrated aspects of signals. Then we will talk about rendering effects. We will talk about the RxJS interop and stores. This is where my talk really connects to Fabian's talk. And then we will talk about business effects. And if you are wondering why there are two kinds of effects suddenly, rendering effects and business effects, also for this I have a sound answer. The result of all of this is we get 3 rules of thumb that help you to use signals in a safe way, and you get 3 hints. So more or less we are distilling out those rules and hints. You know, we are here in Styria, we are distilling everything, even presentations. Okay, cool. So I want to get started with a little tiny demonstration that is also the baseline for everything I want to discuss today. And for this, let me quickly surf this one here. I'm already using the new ESBuild builder, and I'm really a fan of it because you don't see it here on my machine, you don't see it when I'm running Zoom, but it's said to be fast, and it's normally really fast. Don't know what's going on here now. Yeah. Okay, here we go. And here we see my application. Here we see my application. It's about Austrian desserts. I think I'm really an expert into this topic. You can rate all those desserts, like Sachercake 4 stars and Apfelstrudel 5 stars, Palatschinken 5 stars, and of course the best is ice cream pancakes. In this case, 5 stars is not enough. 5 stars out of 5 stars is not enough. That's why we have a cheat mode here. If you double click the 5th star, then you can rate up to 500 stars. And I think, yeah, when it comes to ice cream pancakes, mathematics does not count. Not at all. You can also search for the original German name, like Palatschinken, or you can go, with the English name, which is something with cake, pancake, and then you get also your results. And this is the application I want to use here as a baseline for explaining several things in the area of signals. And I want to get started with computed signals, which is, by the way, the most underrated aspect of signals. And for this, I'm also showing you a demonstration. This demonstration is about the desert component you have seen before in action. And this desert component is quite a straightforward component. We have some signals for our search parameters, original name, English name. We have a signal for the loading indicator, and we have a signal with our desert array, with our result. And first of all, everything is straightforward. We can search for deserts. For this reason, I'm backing up a filter object with the original name and the English name. I'm calling a service with the filter, and I'm getting back my deserts. That's fine. But if we go a bit below, then we see that I have this toRated helper method that is merging deserts with ratings. It is merging both together to get rated deserts. And if you look into load ratings, then it's a bit weird, because I'm loading my ratings, my expert ratings, and then I'm merging the expert ratings into my already loaded deserts. And then I'm setting the deserts. And this is somehow weird, because this all is about ratings. And even though it's about ratings, I'm messing around with deserts. If I implement code that way, I need to remember time and again when to update this object, when to update that object. Perhaps we have 5 locations where we need to update the deserts. If I forget about one of them, then the UX will be somehow weird for the user. And that's why I want to streamline this, and this can be done with computed. So let's switch into another branch. We are doing speech programming here. What I have now is, I have here my desert signal, and I have a rating signal, and the rating signal just takes the ratings. And when I'm loading the ratings, load ratings, I'm just putting the loaded ratings into the rating signal, something everyone would expect. When we load ratings, we do something with the ratings and not with the deserts. And then the magic happens here within my computed signal. My computed signal is calculating the rated signals, the rated deserts, out of my deserts and my ratings. And the good thing is, computed will re-evaluate this expression every time this here or that here is changing. That means we are always up to date. We don't need to remember, well, under this event we have to update this, under that event we have to update that. No, we just populate our signals and everything else is calculated out of it. From an architectural perspective, this is our view model that represents the state we have in a shape we need in this very use case. We might have deserts, we might have ratings, sometimes we just need deserts, sometimes we just need ratings, sometimes we need squeezed everything together, which is the case here. And this brings me to a first architectural rule, which is synchronously derive state where possible. Derive state where possible. This also fits well to functional programming and even more to reactive programming. In those areas, it's not usual to mutate state. Instead of this, we try to derive state from existing variables. And we need to do this in a synchronous way because signals are currently mainly intended for synchronous operations. And also computed only works well with synchronous operations. We should keep this in mind. For async stuff, we need something else. Let's move on to something I'm calling rendering effects for some days. Why for some days? Well, there was a nice post by Alex Rickerbo, who is in the Angular team and responsible for the reactivity story. And he posted this on GitHub. It was part of a discussion within an issue. And he came up with the idea to distinguish between rendering effects and business effects. A rendering effect is something that is doing some rendering you cannot do with data binding. Most of the rendering stuff can be done with data binding, but there are some examples that just don't work with data binding. For instance, locking something to the console or displaying a toast message. Normally, when you want to display a toast message, you call a method. You don't do something with data binding. Or painting something to a canvas. This can also not be done with data binding. So this is what Alex refers to as rendering effects. And then we have business effects, which are just triggering some business logic. On some state changes, we want to trigger some business logic. For instance, every time a value is changing, we want to do something, make a HTTP call or something like this. The thing is, this distinguishing is quite important because the current effect implementation of Angular, and since I really respect it, my life is far easier, the current effect implementation in Angular is mainly for rendering. For business effects, we need some additional patterns, and there are some consequences when going with those patterns. We will talk about business effects in some minutes, but let's get started with rendering effects. For this, let's do a demonstration. When it comes to rendering effects, we can define a constructor, and within the constructor, we can define an effect that is doing some rendering stuff, like printing out the original name and the English name, our search filter. That means every time one of those filters is changing, this effect will be re-triggered. Another good example, as mentioned before, is displaying a toast message. I have a very simple toast service here, and I can use it to display a very meaningful message, like displaying the count of desserts. Desserts loaded. So every time my count of desserts is changing, this show method is triggered. Let's try it out. First of all, let's try out the console output, 1, 2, 3. A, B, C seems to work. And then let's try out the toast message. Let's get rid of this guy here. And now let's search for desserts. And hey, you see it here, 11 desserts loaded. If I say I want to have Palatschinken, then 2 desserts loaded. And we all know which of them is the better one. So those are good examples for rendering effects. However, if we want to do something else with an effect, like first and foremost propagating state from one location to another location, we are in kind of an area where we need patterns that have a lot of consequences. So let's say every time the original name is changing, you want to delegate it to a store or to a service to do some things. This would have several consequences. One of those consequences is that we can end up with chains of change. So we have one change that leads to another change that leads to a further change. And if we have something like this, we have a system that is not controllable anymore. We don't know anymore what happens if we change something here. And we might end up with cycles. We might end up with infinity loops that are for sure not the best thing for your performance. And that's why I will talk about this kind of effects in some minutes. So the second rule here is avoid rendering effects propagating state and signal writes. Just don't do it. Rendering effects are just for the last mile for bringing some state into your view. Let's also talk a bit about RxJS interop. So we have seen it several times. Fabian already did a nice example today with the signal store. Signals really play nicely together with RxJS. And this gives us all the power of RxJS, like all those operators we have there. Something like the bounce time. I think no one wants to write the bounce time by hand. It's really error prone, it's infrastructure code, it's nothing we are paid for. So first hint, signals play well together with RxJS, but there is another hint, namely RxJS is really great at preventing race conditions. So just imagine we search for, let's say, desert A. And before we get the result for desert A, we search for desert B. And before we get the result for desert B, we search for desert C. With RxJS, you have something like a switch map that assures that only the last result is shown. Because we don't want to see all the results for A, B, and C if we decided to switch the filter to C. This would be a race condition if everything would pop up one after the other. So something like this, preventing something like this, is really, really easy with RxJS. And this brings me to another hint, avoid race conditions somehow. RxJS does a great job with switch map and all his or her brothers and sisters like merge map and concat map and exhaust map. But in theory and also in practice, you could also just go with a loading flag, and in this case you disable your search button when the loading flag is true. Or perhaps you have a loading indicator preventing you from pressing the search button again. Of course, if you have a highly reactive use case, where just changing something leads to another search, then you want to go with RxJS, because in this case there is no button you can disable. Let's also talk a bit about stores, and this is where we have a really nice connection to Fabian's talk. So I think stores are really the missing link in the whole signal story, because without stores and without a lot of discipline, you end up with an incredible machine. Who knows this good old game, The Incredible Machine? Yeah, some of you. It's a nice physics game. So I would say the goal of this is to provoke a side effect. You see the bowling ball is going down and is triggering a cannon and so on and so forth. So one side effect leads to another side effect, and this is really a lot of fun. But honestly, if your application looks like this, you really have an issue, because then it's not maintainable anymore. You don't know what happens when you pull some trigger here. In order to avoid this incredible machine, we can totally go with a store. The store is here the missing link. One reason for this is it enforces unidirectional data flow, something that really works nicely for years in the single-page application community. Here I have quite abstract terms like intention. I would say regardless of which store are you using, you are sending an intention over to the store. You want the store to do something. It's about the what, the intention. It's not about the how, because the how is implemented inside the store and or RxJS. Quite often you use both together. And when the store is then doing something, acting like, the Duracell rabbit that is working something for you, then it produces new state. This work can be done in a synchronous way, but more importantly, in an asynchronous way. And then you can use the signals to propagate the new state down, the result of the synchronous or asynchronous operation down to your component, or to be more precise, to your component's view. And when doing so, you can use Computed to get your view models synchronously derived. So currently, this right side here, is where signals shine. This is for what signals have been primarily intended. You can use them somehow on the left side for propagating your intention. This is what we discussed under the name business effect. There are several consequences there. Mainly they are suited for the right side. They are not suited for asynchronous stuff, and that's why I'm really happy we can offload these tasks to a store. By the way, I'm calling this the intention because it really depends on the kind of store how this intention looks like. If you use a Redux-based approach, the intention is an action you are dispatching. If you are using a lightweight store like the store Fabian presented, the NGRX signal store, then it's just about calling a method. That's why I just call it the intention. Which brings me to my third architectural rule: stores make your reactive flow more manageable. So now let's talk about the elephant in the room. Let's talk about business effects. So what is a business effect? Well, basically, it's an effect triggering business logic when a signal is changing, which looks quite easy at first glance, doesn't it? However, it is somewhat critical. It is somewhat critical because in the signals world, we have this glitch-free property. And basically, that means that if we have, let's say, 3 changes in a row, a signal changes 3 times a row, only the final change is used in the effect. So the effect will not be notified about the first change or the second change because it's immediately updated by the third change. And this might be okayish in a lot of cases, but if you really want to express real events, then this might be an issue because events might get lost. I don't say don't use it that way. What I'm saying is be beware about this and use it wisely. If losing events, intermediate values is not a big deal for you, then it's really doable. A second thing is that something like business effects quickly lead to effects writing signals, and this might lead to chains of change and cycles. You might end up with infinity loops if A updates B and B updates C and C updates A. What's the alternative? Well, one alternative a lot of people will tell you about is just using the event behind the signal change. Because in my world, a signal does not change itself. A signal is changed by some event. Might be a click event, might be a mouse move event, might be some data event, like the HTTP client giving you new data. And instead of using the signal change with an effect, you could use this event to do your business stuff, to trigger further actions. This is an alternative, and for sure it might work. However, there is a catch, namely more and more Angular APIs will be signal-based. Think about the router, think about Angular forms. All of them will be updated for signals eventually. And that's why using the DOM event behind the signal change might feel quite unnatural. Because you have a high-level API in Angular, so why use the low-level DOM API? It might be doable in most cases, but it might feel unnatural. And in some cases, it might not even be possible, especially when the event is abstracted away. Perhaps you are in a different layer of your application. You don't know who changed something. You just know something was updated. Perhaps you are sitting inside of your store and waiting for changes. In this case, you don't know that this was a click event or a mouse move event. That means we need some solutions here, and actually I really have some solutions. So let's look into this. Let's go to the right branch, 08. You know, speed programming, 08B. So in this updated version, all my cards have a detail button, which leads to an UI for very humble users. You know, it's very humble. It's just for users that want to see JSON. And we can go through them. We have this next button, and sometimes it's broken. Then we need to remind it by hand. And if you look to the implementation of this, just see this as an example, resampling a more complex real-world approach. If we look to the implementation of this, then we see there is an input. It's already a signal input. It's set up with this magic input function. And this input is populated by the router. So every time we change the route, we get a new ID in the route, and this ID will flow down to this very input here. The router takes care of this. This is this new component input binding feature we have since several versions. And of course, every time I get a new ID, because the route was changed, I need to use this ID for searching for the desert in question. And the first approach is going with ng-on changes, which is valid nowadays. However, there is no ng-on changes planned for signal components, which is one of the next steps the Angular team will give us or work on, a brand new kind of component that is fully signal-based. So in signal components, we cannot use ng-on changes anymore. So what can we do instead? Well, that's now really funny. The first thing you might think you can do is using an effect, and here delegating to your store, to your load function, and passing in the current ID. So every time the ID is changing, this effect will be retriggered. Looks okayish at first glance, but it's really an issue. So let's look here. Here our nice UI is fully destroyed. And if we look there, we see, hey, writing to signals is not allowed in computed or in affect. So it seems like we have an affect with a signal write. Why is this? Where do we have a signal write there? Well, the truth is, the signal write happens in there within the load method. Inside of load, for sure, sometimes we need to update our desert signal. We load a desert, and then we put in the loaded desert into this very signal. And this already shows how affect really works. It not only respects what we have in the lambda here, it also respects everything that happens on the call stack between this and that parenthesis. It respects everything that happens within called methods and also within methods the called methods are calling. But it's even worse. If we would do a signal read in there, like the loading indicator that's readed, then this effect would also subscribe there, and it would rerun every time this very signal is changing. And this is another reason why business effects are somewhat critical currently. So this really shows effects are first and foremost there for rendering stuff. And for business stuff, we have to invent something by ourselves. A pattern a lot of people are using is this pattern here. First of all, grab all the states the effect shall watch on, and then use untracked. Because everything that is untracked is not respected by the effect, or to be more precise, by the reactive context of the effect. And so it will work now. It will only react on changes in ID, and then it will trigger load outside of the effect's reactive context, so there is nothing watched in there. And yeah, it works. Nice. So this is one pattern. And actually, while this pattern is perhaps not the most pretty pattern, the prettiest pattern, it's used in a lot of libraries, you know. It's used in the RxJS interop. It's used by the NGRX store. It's used by the NGRX signal store. It's used in a lot of libraries out there, community libraries that have been updated for signals, like Free Angular Free, which is the FreeJS implementation for Angular, for instance. So we find this pattern a lot. Of course, it's not that pretty. So if we would do an award about the most prettiest pattern, I guess this one would not be in the top 10. But we can make it prettier. I have implemented a simple tiny helper function that's called explicit effect. It's just using the same pattern underneath the covers. However, the first argument is a signal we want to watch on. And the second argument is a lambda that is just untracked and that gets the current value of this tracked signal. And if you ask me, this here is more beautiful, and we see the intention of the code author at first glance. We see at first glance what's going on here. This is another possibility. Then, of course, we always can convert our signal to an observable and go with some reactive magic. Here I'm directly subscribing to it, but instead of this, we could go reactive end-to-end from the source to our destination. This would also work. And then there is a really beautiful solution, and this is where I'm coming back to the signal store. Actually, this here is a signal store, And if you create a reactive method with Rx method, you can pass in a signal, which means the store will connect to this very signal, and the reactive pipe in there will run every time the signal gets a new value. So I think this is the shortest solution. We don't see the intention at first glance. That's why I like to give a prefix to my reactive methods like Rx or like connect. So please note, I'm not passing in the value. I'm passing in the whole signal, and the reactive method subscribes to the signal in there. And beyond us, all those approaches use an explicit effect underneath the cover. So it really seems to be a thing. Awesome. So this brings us to my third hint. Be aware of the options and consequences of business effects. I don't say prevent them, because sometimes they are necessary, but be aware of consequences, which is always a good thing when you are dealing with architecture. Architecture is mainly about dealing with consequences, like the whole life. Okay, cool. So if you like this presentation, then pull out your mobile phone and make a picture here, because this free link, or this link, leads to a free ebook where you find a lot of additional material on all of this. Meanwhile, we have 12 chapters in there. It's in the fifth edition. I think it's even, meanwhile, in the 6th edition. And there is an own chapter. No, there are 4 chapters about the Signal Store. There are even 2 chapters just for extending the Signal Store with your custom extensions. And if you don't like to read, there is also this workshop. This strange guy here is performing sometimes. So look it up. Rumor has it the next installment is next month. It's English and remotely. Okay, cool. So let's come to a conclusion. What did we see today? Well, we've seen several architectural rules. We've seen that where possible, you should synchronously derive your state. Then we have seen we should avoid effects propagating states and signal writes, especially if we talk about rendering effects. And we have seen that stores make our flow more manageable. And funnily, all those rules enforce themselves. So let me just give you a simple example. For avoiding propagating state, you can derive the state synchronously, or you can delegate to a store that does something in an asynchronous manner. Here we have this good old idea of the unidirectional data flow that shows why the store is also here a missing link. And here we have 3 further hints. Signals play well together with RxJS, avoid race conditions, and be aware of consequences of effects and events. And there is one last thing I really want you to remember, namely, if you ever want to have dessert in Austria, Eispalatschinken is the best, believe me. So thanks for having me, and have a nice day. Thank you.